This video covers the paired samples t-test, which is also known as the dependent samples t-test or the within design t-test. When do you use this test? You have one independent variable. It's categorical. It has two conditions or levels. It's a within design, same participants in both conditions, and it has one continuous DV. The goal is to test if two means are different. Now, if you look at Jamovi data entry, you have three columns, but they're different from the last one we ran. You have a participant column, which is an ID type. And then you have two dependent variable columns that are both continuous. And this is confusing, but the first one is the dependent variable when participants experience condition A. And the second one is the dependent variable when participants experience condition B. Each participant, because they're in both conditions, give you two measures of the dependent variable. In most data programs, it is customary to have one row be one participant, and that's why I used the participant column. But this is how you enter your data. Enter your data for your problem. I'm going to once again show you the buttons that I press to get the analysis. So to look at the pattern, we can look at this figure that Jamovi gives us, and we see that the dependent variable in condition B is higher than the dependent variable in condition A. So that is our pattern. Now, in most problems, you'll have a real-world interpretation, and you have to interpret what this means for a normal person. Your p-value is significant. It's less than 0.05. Your effect size is Cohen's d again. Remember, it's 0.2 is small, 0.5 is medium, and 0.8 is large. These are particularly large effect sizes because I'm using very simple data. The first effect size is Cohen's d in the data or the sample. That is negative 16.74. That is negative large. Cohen's d in the population is between negative 24.94 and negative 8.19. So we know the population effect size is between negative large and negative large. Use your effect size ruler. Remember, the negatives and positives are arbitrarily assigned. How do you decode it? You look at the pattern where we have condition A is less than condition B, and that goes along with the negative effect size. A positive effect size would mean condition A is greater than condition B. We don't have that in any of our output, but that's what it will mean. And sometimes you will have negatives and positives in your effect size. You just got to decode what they mean.